Then the first operation we will perform is union. R union S will be mathematically represented by this method pair such that x related to y or y related to x. Meaning this we how do we read this? X is R related to y. This y is R related to x. Mind you, the relations on x related to y is not may or may not be equal to y related to x. If it is reflexive, then they will be equal. But otherwise, they may not be equal. We cannot say they are not equal, but they need not be equal. Right? So the order is important. Relations. But this is in the sense if x is related to y or y is related to x. Next one is intersection. What is intersection is obviously, as I said previously, x is related to y and y is related to x. Meaning, to get an intersection, you see in Venn diagrams, we use Venn diagrams here. So this is this, let's say, the sets of relations. Then this whole thing is R intersection, sorry, or union S. This is called union S. Here, this is just let's say this portion is intersection, meaning only this portion is intersection in the sense x should be related to r and r should be x should be related to y should be related to x. Only then you can have both the intersection. So that is the intersection. Composition. Next property is composition. Composition is denoted with a small circle. That is composition. How we read composition of S or R. Rather, composition of S and R. S and R, and this is how it is represented. That will be like S small r equal to note this difference here. X and z we are saying not so far we have used x and y, we are using z here, right? Such that there exists y x or y and y or z. What is the meaning of this? Let's say it consists of space x and z such that there exists x or y, x is related to y and y is related to z. then like it is a transitive like transitive property like x is related to that. So that is through transitive property x is being related to. So that is the conversion. The next operation we are going to perform is converse. Converse. Converse is mathematically between x and y, if x and y are the sets, then RT, the converse is yx set of pairs yx such that x is related to y. If x is related to y, the converse, as the name itself indicates, is the order pair yx, not xy. This is not what we are using here. We are using yx. The order is yx. Such that x is, if when x is related to y, it is the set of yx, the ordered pair yx. That is the converse. Okay? The name is quite evident. Okay? Next we have complement. Complement is basically rather it is represented like this. The converse is represented with a T letter T with the relation. So as a superscript relation. Here, this is represented. Complement is represented by a arbitrary bar over R. Right? This is equal to xy such that xy belong to x and not x related to y. Are you getting the uh, um, crux of this? This is the pair xy. The pair is regular or order pair or normal order xy, and xy belong to the set x here and not x or y. X is not related to y. Here it was x was related to y. Here x is not related to y and it consists of the ordered pair x, not x. Okay. So those which are not related to elements which are not related to the other element and the order is regular. That's the difference between complement and converse. Let us see the relation. We will see the relation. So obviously they were quite opposites. So the relation is uh, converse is equal to complements converse. Are you can you distinguish between? This is basically complement. Rather, we can say write it down. Complement of converse upper is equal to converse of combination of good. So that is an important property. Now we have restriction. Next, next equation. Then, or how it is represented. It is represented as this restriction to xy, ordered pair xy, the set containing ordered pair xy such that x is related to y and xy belong to S. Here we should mention this. R is relation over X, and there is a subcondition. S is subset of X. X is subset of X. The set X. This is relation. This is relation. R is relation over X, and S is a subset of X. Then this R, the restriction is this one. X, it contains order pairs xy such that x is related to y and xy both are belong to S. This is S is nothing but subset of X. And then there is a small cliche here, which is like okay, let me write it here. Yeah, R is the such that x y and x belongs to S. This is called the left restricted. Left restricted xy such that x is related to y and x belongs to S. Meaning, let's say this is x, this is y, right, right, R and S we should have S. Then x belonging to S, x should belong to S, relation S, not and the condition is x is related to y, x is related to y, x is related to y, and x belongs to S. So it should be yes. This should be. So this will be left restricted. Now we have, as you might have guessed, we have right restricted also. So what will be the right restricted part? One is equal to x is related to y and y belongs to S. Here x belongs to S. Here y belongs to S. They give kind of students. Yeah. So that's kind of left and right related restricted relations.